Welcome to a new video in my home automation series, and today I'm reviewing another Netio product. I think this is probably the third one now, and this is the PowerDIN 4PZ. And I think this is going to be a fairly long video because I've already done the recording for the rest of it, and I know it is a quite a long one because again I wanted to cover quite a lot from this device, and then yet right at the end I realized that I probably only covered about, I don't know, maybe third of the capabilities, because just like with other Netio products, there is a lot that you can do here, mostly because of the various protocols and the way that you can communicate with. And I can't even cover all of the options. So even in today's video, I'm just going to focus on MQTT. So I recommend that you look at the chapters, and then if you don't have time for the full video, just skip to the parts that you are interested in. And by the way, I'm going to reuse some of the things that I've done in my previous Netio videos, because there are similar functionalities what we have seen on other products. But I have to say that this is like the Swiss Army knife of the Netio products, or Swiss Army knife of home automation, because you can think about various scenarios that you might want to do, things that you want to control, and then probably this device is going to do that. So let me go through the main specs and tell you what this device is capable of. Up until now, we have seen Netio devices that can control things, switch devices and measure power and consumption. And this device is no different. As you can see here, we have two outputs, out 1 and out 2, and they are switching the input mains, and they are also metered. So you have two outputs where the device is going to measure voltage, current, load, energy consumption, phase shift, and frequency of the mains power. Very similar to the power cable, but now with two outputs. Also, there is two more outputs, output 3 and 4, and they are just simple relay outputs. So you have access to the three relay terminals, common, normally open, and normally closed. So that also allows you to switch mains voltage, but you can also switch DC voltage, or you can use them as a dry contact. Of course, these two outputs are not metered. And above all this, now we have a device which has inputs as well. So we have two digital inputs. As you can see, they can be used with a simple switch. So you just short the common and the neutral, and they work as an input source. But on top of that, these two inputs can also count. So they can count the number of impulses internally. So you can get the state of these input, or you can get the counter values. And I think this is very useful because these counter inputs can be used to hook up to meters. So for example, I have a domestic gas meter in my house, and that gas meter has a small recess where I can plug a reed switch. So actually it gives me a pulse of every, I think it's 0.1 cubic meters of gas used. So you can use a digital input counter to count the or to count the gas usage. And similarly, most of the new water meters, they also have an option where you can put I think it's a reed switch. So then you can count how much water you are using. So these two would be ideal in a residential setup where you can connect your gas meter and your water meter, and you can just measure the consumption of these two utilities. So these are the main inputs and the outputs. And this device is designed to be more in like an electrical cabinet. So on the back we have DIN rail mounts. There are also screw mounts, so you can decide how you want to use it. And in terms of the connection, again, you have options because there is Wi-Fi built in, but there is also an Ethernet jack. So you can decide whether you want to access it via the Ethernet or via Wi-Fi. And what is similar to the other products is this supports all the communication protocols that we used with Netio. So you can use an XML HTTP API, a JSON API, simple REST URL calls, MQTT, Modbus, and I'm just trying to think about all the other options, but we are going to see it later in the video. And now there is also a Netio Cloud, there is a mobile application, and actually these are the two things that I'm not even going to cover in this video. Maybe I'm going to revisit in the future. So you can just control it on your mobile phone, and Netio is providing you with a secure cloud server that you can communicate through. And then probably other feature that I also like, even though I haven't used, you see this NFC logo here. So you can use the mobile app to do the configuration of the device, and then use NFC just to transfer the settings over to this unit. So again, it makes it really easy to deploy these make changes to it. Of course, on the online management page, you can also do all your settings. You can save the configuration, load the same configuration on the other device. So they really thought about how you make your life easier, especially if you have multiple of these devices and if you have to manage and set them up centrally. And the last thing that I wanted to mention, hopefully I'm not leaving anything out, then the relays that are inside, even though they are physical relays, but the device is monitoring the AC voltage and then it does a switching when the AC goes through the 0 point. So that should ensure the longevity of the relays that are used in this PowerDIN. And you can see it here, out 1 and 2 is rated for 16 amps and out 3 and 4 have a 2 amp relay, but still they can switch mains voltage. So there is a lot to cover today. I'm going to make references to my past videos about Netio products. So I'm going to leave the links to those videos and also links to the configuration file that I used, my Node-RED example, and they are all going to be in the video description. First of all, let me show you the very simple setup that I've created here. So as you can see, the PowerDIN is mounted here on the board. In this particular case, I just screwed it in. I didn't use a DIN rail. And the mains power is connected here. I'm using Wi-Fi, so the network cable is not connected. I have two simple DIN key push buttons on the two inputs, so on input 1 and input 2. So they are basically connecting the common and the IN 1 and also the common and the IN 2. So I'm just grounding those connections when I push the button. And on the 4 output, I'm using these status lights, which are going to be nice for the camera, so the camera image is not going to overexpose. The only thing is that these are basically LED status lights, so they consume next to nothing. So we are not going to see a lot in the current and the consumption screen. And I'm just powering them from mains. Of course, the output 1 and 2 is mains powered, but I've connected the mains to output 3 and 4 as well, so they are all getting mains power. And that's pretty much it. And now let's look at the administration screen for this device. I've already logged on. I use my mobile app to find the IP of the device, and you just put it into your internet browser, and then you log in with the default password of the user, which is admin and admin. I haven't changed that yet. And right in the beginning, you see the 4 outputs that you have, and you can just control them from here as well. And as you can see, I have output 1 and 2, which are the power outputs. And even with this small load, we can actually see some current being drawn. So 16 or 15 megawatts, which is, yeah, it's about, well, it's less than 1 watt. So it hovers between 0 and 1 watt. You can see the voltage, power factor, the energy used. Because I haven't used this device to power anything else, the energy is really, really low because, as I said, these LED status lights, they consume next to nothing. So you can see that for the first 2 output and for output 2 and 3, because they are just simple outputs, they don't have power consumption, so they just either turn on and off. And with each of the output, you can click here as well. You can change the output settings, so you can change the name of the output. You can specify what is a short on-off delay, so it will be possible to change these outputs or switch these outputs to only momentary switch on. So they switch on and they automatically switch off, and that's the delay. So that's a little bit over 2 seconds. And you can also specify what the power on state should be, whether it goes back to the last state or it always goes off on or. And you can even specify a power up interval. So if you specified it as on, but you specify a millisecond delay, then it will only come on with that specific delay. So if you want to power all the outputs on, but you don't want them to happen at the same time, just to not to put extra load on the line, you can just delay the outputs here. So that's actually quite nice. So that's the main control surface for the outputs, and we have a similar one for the input as well. And as I said, it works as a simple input, but it also works as a counter. So if I push one of the buttons, then you can see that the state is on because I kept it pushed. And if I let it go, then it will go off, and then the counter should increase as well. And the same with the second output, on and off, and then the counter increases. Maybe there is a logic in the counter that if I press it for too long, then it doesn't count as a counteraction. It has to be a short enough pulse for the counter to increase. But I guess you would either use it in one of the modes or the other, so it doesn't really matter. By the way, my switches are quite bad, so sometimes they don't register a click, what you can see here. For example, now, yeah, I think I pressed it twice, but it only registered once. But that's down to my switch. There's nothing wrong with the unit. I'm going to skip the protocols. I'm going to do that last. And because there is so many to cover, again, I'm not going to talk about the cloud at the moment, but it is possible to control this device over the cloud and with a mobile app. And next, you can set up users as well. So we just have the default admin user. So if you want to give access to particular users, but only, let's say, just to change the outputs, or maybe just to monitor the power consumption, you can add them as, you know, guest user and or simple users or just guests. In the settings, we have option to change the Wi-Fi. Actually, this was really useful because the easiest way for me to set up this unit was to connect to the network cable and then come to the administration page, and then I configure the Wi-Fi. And probably that's the easiest way to do that. And then in the network configuration, you can also change whether you want a DHCP address or a static address. And you can even define it for the Wi-Fi and separate for the Ethernet connection. The device can set its own date and time, so you don't have to worry about that. And there are a couple of options to change firmware, to update or install a new firmware. I haven't done anything like that yet. And there are a couple of system settings. So that, for example, here you can change the device name, which we are going to use in the MQTT. So just be aware that this is where you are going to change that. Or if you want to move this admin page to a different port, then you can change that as well. And there are a couple of features here. So for example, if you don't know which device you are controlling, you can click on this locate, and then it's going to blink the Wi-Fi icon. So if you have 5 of these and you don't know which one is which, this is how you can find out. You can also reset the power consumption counters, factory reset, and also once you have done the configuration for one, you can just export it and then import the configurations. Again, it makes it easy if you are setting multiple of these units up that are going to be, you know, fairly similar. And finally, we just have some logs on, you know, what's happened, who logged in, what got changed by what sort of message. For example, I've configured this for our MQTT, so it's going to, you know, have all the MQTT messages. So that's the, you know, the general setup, and now we get to the main part, which is this M2M API protocols. And as I mentioned before, there are so many different protocols that are supported by this unit, and if I want to explain all of them, I think we will be sitting here all day. And because, you know, my main focus is usually home automation, I'm using MQTT. I think I'm going to spend some time on MQTT, but this is not the first time that I've reviewed products from Netio, and I think when I did my previous video, I also talked about Modbus TCP. So again, if you don't really understand how that works, you know, you can look at that video. It is going to be really similar. I mean, technically the difference between this product and some of the other Netio products is that it has different number of outputs. And, you know, not all the outputs are measuring power consumption and, you know, power metering. But other than that, it should be, you know, the general working is going to be fairly similar. And even though I'm not going to go into the details of each of these protocols, as you can see, once you select one of the protocols, there is usually links of various documentation how you can find that. And if you go into the Netio website and you scroll down, you can read about all these protocols, and for all the protocols there are a couple of application notes where they show you examples how you can do that, but you can actually click on the protocol and you get a, you know, proper documentation how that works, and you get some examples and, you know, for example, how the JSON protocol looks like, what sort of messages you need to send in order to control the device. So everything is documented. But just quickly go through all these. The first one is the XML API, where you can send in XML messages to an HTTP endpoint, and that XML message is going to control how you want the outputs to be set, whether you want them to be on or off, and of course you can do multiple of these, but everything is an HTTP request and the details are going in an XML file. The JSON API is actually very similar. The only difference is that the actual data or the commands that you are sending in, it's not in an XML file, but it's in a JSON string. Again, you can see some examples how that would look like here. The third one is the URL API, and Here, again, we are using the HTTP protocol, so there is a specific endpoint you need to send the messages in, but here you are controlling the device with a simple URL. So all the commands, how you change the outputs, are in the URL itself. So if I look at this example, you can see here on the status that you pass the output 1 equals 4, so that's going to toggle output 1 on the device. In the telnet option, you can use telnet to control the device. In Modbus TCP, well, as the name suggests, you can access the device through Modbus TCP. Again, probably you have to refer the documentation on how exactly you can get all the different registers. Most probably you have to use the combination of coils and registers, so the outputs are going to be coils, and so the measurement data, for example, the counters or the power measurement data or power, current, that sort of stuff, are going to be various registers. And this unit is particularly complicated because it has two different outputs that are metered, and it also measures the overall consumption. So pretty much all your figures are going to be in 3 different registers, or 3 times, because you can get the data for the individual channels, output 1 and 2, and the total as well. And as you can see, for the Modbus TCP, you can even filter the IP addresses from where it is going to accept requests. MQTT Flex is, well, that's my favorite protocol, and if you have seen my previous video on Netio, it's going to be fairly similar. You are configuring all the MQTT settings, like the topics and what topics to publish to, what topics to subscribe to, in a JSON format. So I'm going to go through that in a few minutes. There is also a Netio push protocol, where the device is going to send updates to a specific URL that you can configure here. So like current data, consumption, output states, so they are going to be sent via HTTP. And finally, we also have SNMP. So this device can be centrally managed, just like any industrial or network devices that support the SNMP protocol. So your IT people will be able to remotely monitor this device just to make sure that it's working fine. And one important thing about these protocols is when you pick a protocol, that protocol is getting enabled, and that automatically disables all the other protocols. So you just have to figure out what is the protocol that you are going to use, and if you pick that one, well, that's going to get enabled and all the others will get disabled. So you can't use MQTT and the URL API as well. It has to be either or. And with this, we arrive to the MQTT section. So here I'm going to talk about how to configure this MQTT JSON or MQTT Flex configuration JSON. And actually, pretty much everything was already set up by default when I enabled the unit. So the only thing I had to do right in the beginning is change my MQTT server details. So the URL, the username and the password. And I'm using non-secure MQTT because, well, it's local. So I just left the port on 1883 and the SSL, I left it on false. And if you remember from my previous video, the rest of the MQTT Flex configuration are going to be 2 main topics or 2 main attributes. One is the publish and the other one is the subscribe, which is further down. The difference with the PowerDIN as opposed to the power box or the power cable that I reviewed previously is there is a new option now how you can send messages. If you remember with the other models, I had to create a topic for like the power and the current and the voltage and the the power consumption and power factor and the output states. And now what has changed is there is a new topic, and now there is a new publish option which is called the output status, and this output status is going to be a JSON string which is going to contain pretty much everything about the device. And I know it's something pretty new because actually at the moment it doesn't include the input, so it contains all the power measurement data and the output states, and then the inputs are going to get included very soon as well. But I wanted to get this video out. Probably I'm going to come back to that a little bit later. So instead of creating all these different topics, now we just have one topic, which in this case is this Netio and device bound, and we are going to see later on that this is going to send a JSON with a lot of information in that. So To some extent, it could be easier, it could be more difficult. I mean, if you want one specific data, then you can still modify this JSON, and you can just create a topic for that specific data. For example, if you are only interested in the power consumption of output 1, you can create a separate topic and you will get that single data. But in here, in this output status, we are going to get everything. And because the output status doesn't contain the inputs, well, obviously, I've also created 4 different topics where I can get the input 1 and the input 2 S0, so that's the counter, and also the input 1 state and the input 2 state. So if I want to use it as a counter, or if I want to use it as a switch input, I have these topics, and they are configured to automatically send a message whenever either the state changes or the S0 value changes. And also on the subscribe side, things has changed a little, because in the past I would have created one single topic for every output to change the output state, but now there is an option here as well. So now you can specify the target as the REST JSON, and so you have only one single topic, which is called the, well, in this case is /message/events. Of course, you can change this topic, and then you send a JSON to that, and that JSON can contain how to switch the outputs. So it could be a little bit more complicated because you have to put the JSON together, but in that JSON you can actually control multiple outputs at the same time. So we are going to see examples of that, but it is completely up to you. You can go back to the earlier examples as well, so you can create multiple topics. So I could create 4 topics for all the 4 outputs, and instead of sending a JSON, I can just send zeros and ones to that. That would work as well, but I just wanted to show you this new option for this device. So I think that should be all about this configuration JSON. By the way, I'm going to include the link to this JSON file in the video description if you are interested in that. And now I think it's time for me to go back to the Node-RED example. And this is quite a big flow because it contains all my, Netio examples from my previous Netio devices. So let me scroll back to the button where I have the PowerDIN examples. So first of all, if I want to receive all the messages from this power box, I can just enable this topic and I will get all the messages. But let's first receive some updates. So this is the device bound topic that I talked about. That's the one which sends the JSON updates. And actually I can trigger it by pressing one of the input buttons. And we are going to say, actually it gets triggered twice because the input goes to 1, and when I let the button go, it goes back to 0. And you can see that it contains an object. Within that object, there is a global measure object. So that's where you can see power consumption data related to the, both of the outputs. So this is measuring totals on the whole device. And when you go into the outputs, which is an array, we can see the 4 outputs. And if you start expanding that, you can see the first output, which has a state, and it also contains the power measurement data, similar to the second one. That's why I said that when you look at power measurement, you have 3 power measurements for output 1, output 2, and also you have combined. Once I open output 3 and 4, which, because it's an array index, it's indexed as 2 and 3, they are going to be much simpler because, well, they don't have power measurement. So they only have a state, and there is a delay that we have set previously on the screen, and that's it. So the way the MQTT Flex is configured, that anytime the output changes or the input changes or the consumption changes by a certain value, then this message will come through. So everything will come in a single message. And you can slice and dice this JSON or this JavaScript object and get the data that you really need. So I don't think, especially if you are using Node-RED, it is really easy to get information out of an object. So I don't think this is a disadvantage to using separate topics for each of these data. I mean, probably you can see there is probably like 50 of them. So otherwise you would have to have 50 MQTT-ins. The next one is how to operate that events, or how to use that REST JSON format. So if you remember, there is again a specific topic where you can send messages to, and then within the message you specify how you want to operate the outputs. And that message is actually a fairly simple JSON message. If I open this up, you can see that the JSON contains an output object, which is actually an array. And in that array, you again have objects which have an ID. So that could be 1, 2, 3, and 4 to identify the 4 outputs. And it can also have an action. And this action is again a number, and that can have multiple entries. So for example, 0 is turn the output off, 1 is turn the output on, and I think 3 is a momentary, and 4 is a toggle. So I can, let me turn all the outputs off. Okay, so I can, toggle the first output. I'm just sending these messages in, and by the way, you can see that this device bound, so this global object is getting sent every time I change the output. So to change the output 1 to toggle, I send ID1 and action 4. And if I just want to switch on the second output, then ID2 action 1. If I want to switch it off, then it's ID2 action 0. If I want to operate 2 outputs with one single message, so if I want to turn 3 on and 4 off, then that's the examples that I've shown before. So in the outputs you have 2 objects, ID3 1, ID4 0. And if you want to do it the other way around, so turn 3 off and 4 on, then you almost send the opposite message. So 3 0 and 4 1. And if you want everything to be off, well, there was only 1 on. So that's, 4 objects with ID 1, 2, 3, and 4, and the actions are always 0, or 0 for all of them. And if you want to have the momentary option, so that's channel 1, and with the 2020 millisecond delay, it's going to turn off. And that's action 3, that's the momentary. So I think I said 4, so it's always 3. And by the way, these actions, they are the same actions that you would use if you're using the JSON API or the XML API or even the URL API. So you still have to send in output 1 equals 4, and that's the same toggle that I used here as action 4, and probably the same apply. And the same applies to XML and JSON as well. And to also cover the inputs, I have 2 examples. These 4 inputs that I've configured at the end of the MQTT JSON to control the counters. So if I enable this debug and if I press the first button, we can see that we are getting the message on the input 1, and it's a simple message. It just contains the counter value. And if I press the other one, it's going to be the other counter value, which also increases. And it's good because then this device remembers all these details even if it gets powered off. But if I want to use the inputs as switches, then I use the other 2 topics. And if I press the first switch, we receive a 1. So it got turned on or closed, and then now it's open again. And pretty much the same for the other one as well. So yeah, just like as you would expect from any switched input. And as you can see, there are a few link nodes in here, which I haven't really connected to anything yet. And I also have some UI examples, and this is actually something that I've created for I think it was the UI cable. So I've done 3 separate options. So first of all, you can, control the device. Well, that hasn't changed. So that is pretty much wired for a control cable as well. But we have seen how we can send messages, for various actions. You can just send the same messages whenever you press this button. So you can configure the same JSON string for the button output, and you just wire it into the events topic, and that would be it. Of course, you can get the live consumption data, and probably the easiest way to get it is to get it from that global JSON, and then you can again decide whether you want a power for the total or for output 1 or output 2. So potentially you can, duplicate this section like 2 more times if you want to get all the data on your screen. The other thing I was doing is this consumption logging. And actually for this, I think I'm going to overlay the video from my previous YouTube video where I actually covered this with some live data, which is going to be more interesting than just looking at a simple graph. But basically what happens here in this consumption logging, you link in the voltage data that you get, so the load data that you are getting from the device, and it's going to automatically plot this data. So you get an idea how your device is using power consumption. And also, besides getting the data, this flow is automatically going to aggregate the information. So let's say the data is getting received every second or every 5 seconds, but then the log is going to aggregate this data to, let's say, a 30-second interval or 5-minute interval, and for that interval it's going to calculate the average consumption and also going to monitor the minimum and the maximum consumption. So you can see how your device is consuming power in a period of time. And in this chart you can also save some of these logs and you can recall some of those logs later on. So it's really just to monitor your devices, to see how they behave, and maybe just to discover some irregularities, how they operate as opposed to how you expect them to operate. And the other thing is a power statistics, where again you are feeding in the watt hours or the kilowatt hours data that you are getting from the device, and that it would automatically calculate hourly consumptions, daily consumptions, and weekly consumptions. And I've originally created this flow so that it measures rainfall. And the rainfall data for me is coming from a weather gauge, which is giving me the cumulative rainfall in millimeters. So it just basically calculates how much the data changes. So this flow doesn't really care whether that data that continuously increasing, whether it's coming from a rain gauge or it's coming from power consumption meter, or actually it's coming from a gas meter in terms of clicks, or it's coming from a water meter also in terms of the clicks. So I think this flow is actually ideal either for the power consumption data or either for the S0 or the S1 data that comes out from this unit. And this is why I haven't finished this flow, because as you can see here, if I scroll all the way to the top, here I have the power consumption logging logic, which creates all these drawings and saves the data and then, you know, puts them on the chart. And all it needs is an input. So it needs an input where the continuous data is coming in. So I've created this LinkedIn node, which is called the power consumption logging in. And here you can decide what to want to feed in, because you can feed in the total load, which is the combined output 1 and 2, or you can do output 1 or output 2. Or if you want to have all of them, you can just duplicate my flow, so you have 3 of them. And here I have already done the change node, which is going to get that specific data out from this JSON. And so you can just connect whichever you want, and that would feed the data into the flow. And very similarly, I have the second flow, which is the power usage statistics. And again, it expects a single value, so just a number which is coming in, and that number can come from the energy monitoring. So that could be the total energy or output 1 energy, output 2 energy, or it could be the S0 inputs for either input 1 or input 2. So that's why I said, if you want to use it as a monitoring device, you can connect, let's say, a gas meter or a water meter to this input. And this flow would be able to monitor your, hourly or weekly or daily gas or water consumption. And just like with the previous flow, if you want multiple of these metering, you can just copy this entire flow like this one and then duplicate it. Of course, the only different thing is that you need to make some changes because, well, these flow and also the other flow store some information in the local context. So you can see, well, actually it's a global context. So you can see that the information is stored in the power_netIO variable. So if you have multiple of these, you have to rename these, otherwise they would overwrite each other. So, your first flow is going to be power_netIO, I don't know, total. The other one should be power_netIO, output 1 or something similar, or input 1 or gas or, water. And also here, if you want to use the database update option, so this flow is going to log the hourly, the daily and the weekly consumption to a database. And by the way, you can find how you need to create the database if you want to use the exact same structure. And here in these function nodes where I create the database update SQL. Here you can see this parameter is the device ID. So again, if you have multiple, just pick a unique one for each of the examples. So that's the SQL for the hourly update. There is an SQL for the daily update. Again, you see here Netio, so you probably want to change that to, again, total, gas, water, whatever you're going to use it for. And there is also one for the weekly. And of course, you can go into the same table, so that's not really a problem. The table is designed to hold readings for multiple devices. And probably the other thing that you also need to update is, as you can see, the chart status is always saved to a file. So if your node restarts, then the chart doesn't start from empty, and you specify the file name here as well. So if you have multiple of these examples, you just need to provide unique names here. So the chart dump nodes, they all need to be updated, and there are similar chart dump nodes here. And I think there is a similar one here as well for the power consumption logging. So that's about the consumption logging, and if you want a really detailed explanation of these, I recommend that you watch my other video. And I've also done some simple automation examples. And again, you can decide what to link to these inputs, which input of your PowerDIN. So for example, here this flow can do monitoring on your consumption, and let's say if your hourly or daily consumption, or in the last 24 hours the consumption exceeds a certain level, then it's going to do something. So for example, you can turn one of your outputs off. So you can specify your JSON in here. You can just copy the JSON examples that I've used on the inject nodes. So let's say if on output 1 you are running a pump, and you know that that pump is definitely going to consume less than, I don't know, 200 watt hours per day. But let's say, for example, your float switch is stuck and you don't have a water sensor, but you can probably tell that if the pump is using more than, I don't know, 500 watt hours, probably something is wrong and you need to shut it down. So you can send a command to turn off output 1. So the pump is going to turn off and not going to pump water unnecessarily. And here I also have a small flow which is monitoring how long a certain output is on. And here you can again plug in any of the data that you have from this device, which can actually be any of the outputs. So there is an example here how you can get, not energy output. So output 1 state, so that would be state. And of course, if you want output 2, 3, and 4, then you can change this value to 1, 2, and 3. But also you can also measure, for example, how long the input could be on. So if it's connected to some sort of sensor which senses if something is on or off, or if something is open or closed, you can count that as well. And then if it reaches a certain value, for example, if it reaches 1 hour, which is 3,600 seconds, then you can do something. Again, maybe you can change the output, switch them off, or for that matter, switch one more output on. So that's the sort of automation that I've used in previous examples, and they are equally valid to be used for the PowerDIN as well. If you are interested in any of the things that you have seen in the video, if you want to purchase the product, I'm going to leave a link in the video description. I'm also going to leave a link to previous videos on Netio devices, so you can get some inspiration how they work, and then maybe I've explained similar things in a slightly different way. Or as I mentioned in one of the videos, I used the Modbus example, how you can control the device over Modbus TCP. And of course, the link to this Node-RED flow is going to be in the video description as well. But I think that would be all for today. Thanks for watching, and hopefully see you in the next video.